Hello everyone, I just reviewed a cassette deck with 2 valves in it because everyone knows that valves sound marvellous. It was an expensive piece of kit, so it kind of inspired me to hold one of these cheap valve preamps that are supposed to do the same things as was happening in that cassette deck and have a look at it. Bought from Amazon. Look, they stuck the label directly on the box, came through the post just like that, which is not good. And it is it's made by a company called Nobsound. Yeah, Nobsound. And tube preamp that can greatly improve the quality of for amplifiers or active speakers. 3.5mm outlet, takes a variety of different valves. I think they're all triodes. 6BC5, all that lot. EF40. That's a pentode, I believe. Low noise. Anyway, so it can take all those valves. I'm not sure what valves we've been given. Connect to the audio source, connect the power adapter, press the red button, play music to your audio device, rotate the volume knob or tone knob to the best sound. Enjoy hi-fi music. Well, is it hi-fi? If it's been distorted, we shall see. Gain 1.5 to 2.0 times, frequency response 20 to 30 kilohertz, where you can't hear 30 anyway. THD less than 0.005. Well, how can it be THD of 0.005 if the idea of the valve is to distort the signals? Interesting. Signal to noise 110 dBs, 6 volt 2 amps, so it's 12 watts with the heaters in the valve. So it's using up power. That's what it looks like. Got bass, treble, volume, usual stuff, Nobsound. And there's the manual if you want to look at it. So it's about £45, I think. I don't know whether I'm going to keep it or not. Let's see if it works. So let's get it out of the box. So here it is. You've got exactly as it says on the tin. Very notchy controls and hard to get hold of. That one's quite a bit stiffer than this one. It is clicky. Can you hear it? Sorry, over there. Not great. They don't feel damp. They just feel kind of rough. Quite sharp edges on them. Volume control, bass and treble. Socket for 2 valves, and then in out and power, just as we saw in the instructions. And here's the valves. We have Chinese valve. Is that a 60X? Is that a triode or a pentode? That seems just to be a triode, that one. Yeah, basically a pentode is just a triode with some extra grids for screen and suppression. But it won't make any difference in this arrangement. Plug them in. And then fire it up, shall we? So that's what it looks like. It's quite weighty actually. Should I take it apart and have a look inside? Could do, couldn't we? Anyway, let's try it out. Well, here she is, all plugged in, warmed up. Let the electronics warm up, or the heating elements inside the valves. Can you see them in there? So you got a little hint of the heating elements showing up. I think you can see them. That's the overall effect. It's quite hard to turn these controls. The thing slips around a lot. Could do with some non-sticky feet. But anyway, it's all plugged in, and it is plugged into the HP 8903 analyzer controlled by that computer, connected to my computer. So let's do some sweeps on it so you can see how to set this thing up, and we'll just have a very quick look, and you can well, get a better idea before you buy this thing to see whether it's going to improve your sound or not. Right, okie dokie. This is the display from the 8903B frequency sweep audio analyzer. This utility controls it and is connected to it, so you'll see the results in real time appearing on here. And what we're going to do is we're going to scan through the frequency range and see what the gain is at each frequency, so we can map out the frequency response curve of this Nobsound. Knobby Nobsound. Alright, so if we set start, it'll set the reference. So it's 0 dB now, so that will be the 0 reference at 1 kilohertz, I think. And if we press OK, it should start to scan. And you'll see the lines start to appear here. It's gone off scale immediately, which is not good. I was expecting it to be flat. There we go. So it's 100 Hertz. We've got some gain in there, so it's not flat when the controls are set to the central position, which is always a bit of a worry. But immediately when you connected this up and you set everything to mid position, you'd hear a bass boost and a lower mid-range boost as well, which always sounds a bit nicer than without, especially on small speakers. Okay, and you can see going up to 30,000 Hertz, it's pretty flat. Let's zoom in a bit further on that. So that's what the response looked like. Actually, above 1,000 Hertz into the all the way up to 20, you've got a 1 dB drop actually, so it's not flat at all. So not only is the bass not flat, the treble's not flat. So if I just turn the bass up, I'll go full bass and run another trace. Bass to the trace. No, actually, I think I must have twiddled the treble. That's full treble we're working on. So obviously the bass is going to be the same. We're going for a full treble boost here. See how many dBs of treble we get. Interesting, it caused a bit of a trough in the lower mid-range, didn't it? Crikey. Alright, so we've got, it rolls off at 5 dB, so full trebles plus 5 dBs. Minimum treble coming up. Turn the treble down fully anti-clockwise. Yeah, you can see the red line now. So minimum trebles actually increase the gain lower mid-range slightly by 0.2 of a dB. Wow, that's some roll-off. That would sound like you've got your head in a bucket, in a box, in a room. And you can see it's gone down to minus 20 probably. Yeah, so that's a hell of a roll-off for the treble controls, and it's affecting the bass slightly. So there's your treble, there's your flatness. I wonder if we do a fourth one. If I just set the treble to, say, 1 o'clock. Treble is set to 2 o'clock now. I'll say 2 o'clock, and we'll do the final thing, see if we can get any flatness around there. So in the actual treble range, whether we actually can get the thing to be flat. There it is here, look. Hasn't made hardly any difference at all, if any. It is rolling up, so you get it flat up until the 15 to 20 kilohertz. Alright, so let's just do the same thing with the bass. Right, here's the bass. That's with bass flat, as we saw in the last scan. So if I just turn the bass up to full bass, so that's bass fully clockwise, do another track. So here I have the yellow line, which is a standard bass in the mid position. This is maximum bass. You can see it goes up to something like 8 dBs up at 90 Hertz and then rolls back down to 0. So nice bass response there. But this is with the bass control turned fully anti-clockwise. And that's pretty strange. Look, it's caused a roll off of gain at minus 5 dBs. So the actual bass control, when you turn it fully anti-clockwise, not only is cutting the bass, it's also acting as a volume control up until, well, across the whole range. So it's turns the bass right down and then also affects the volume. So that's very strange action on the bass control. Not been designed properly, the bass circuitry on that, I would say, or tested. But it is what it is. So now, yeah, so weird tone controls, more or less flat, but you can't get away from the bass boost. If you turn the bass gain down, you get a dip down here, so you can't make it run flat. But then I guess that's probably designed to make it sound better as soon as you connect it. You get an instant bang for your buck even before you turn your tone controls. So if we go out of this and just look at the total harmonic distortion. So this is a total harmonic distortion racking up on the bass line there. And you see we've got down to about 0.3% at the outset, and it's hovering around 0.3, 0.2%. Which is not the 0.001% in the actual book. So the book is completely wrong. It's not an audiophile low distortion. But you think about it, if it's supposed to introduce distortion and give you that lovely valve sound, then you know, you wouldn't expect the distortion to be too low. If the distortion is too low, then you're not getting any added distortion is what you're paying for to get the valve sound. Therefore, you expect some. You want some because that's what you want it to do. But when do you want it to do it? And that's the other question. So yeah, anyway, look, we've gone out of 0.2%, so not great, not bad. Not sure what to interpret. Maybe there is some valve sound distortion. Let's put it on the spectrum analyzer and connect it up to the Rotor-Schwarz generator. Let's have a quick look at see if any harmonics are coming out this thing or not. Hopefully they will be. Okay, so we've got the preamp in circuit. This is the 1 kHz 0 dB signal coming in from the Rotor-Schwarz, and you can see it on the screen. The frequency along the bottom up to 20 kHz. Actually, this is 1 kHz. That's a 5 kHz spanner we've got at the moment, I think. And we're 1 kHz going in at 1 volt. So if I just turn the other input on, you can see what's coming out. Right, volume control is set to halfway. Tone controls are set to midpoint there. And you can see you've got an even harmonic coming out at, if I move the part, you can see this bright spot on the top is the marker. So that's 52 dBs down, so we've got a very small harmonic spike coming in at 52 dBs. That's the even harmonic at 2000 Hz. So 52 dBs, what's that? 2 millivolts? Very low level voltage coming out, power coming out, so you wouldn't really hear that. So if I just turn this up to full volume, so I'm turning the volume on the unit to full, still at midpoint, and we have another harmonic come in at 3 kHz. So that's the second harmonic there. Okay, so it looks like if you want any sort of a harmonic content to be included, which is what the valve sound is supposed to do, then you have to run this. That's just below half, look, and all the harmonics have disappeared. So I just go between, just turn up a bit, you get a bit of the second harmonic, turn it up full power, you get the third harmonic. So let's look at the most significant one of these, is the minus 34 dBs. Let's just work out what that voltage is. Yeah, so that's 8.9 millivolts versus a volt. Okay, so that's 0.01. Yeah, 0.01, that's 1%. Is that enough to be heard, we wonder? We don't know. We'll find out, won't we? So that's what you get. You do get some harmonics, but you have to run your volume control above 50%. Well, that is the Nobsound. The Nobsound NS-10P. Worth about 10p and all. Right, so feels quite solid, quite weighty, nice piece of aluminium extrusion. The feet are too skiddy. It's too close to the deck, so that when you go to turn these, they're quite stiff. You can't get your thumb between them, and you just hit the deck all the time. And they are quite stiff and notchy and quite sharp at the edges. So they look the business, but they need to be scaled up. So you've got some nice big controls and maybe some bigger valves, but that's just the aesthetics, because I think honestly all you're going to get from this is the aesthetics. What I'll do in a moment, I'll play you the harmonics, so you'll see what that minus 53 dB relative to the fundamental sounds like. In fact, if you can hear it at all, the ratio of the main signal to the harmonics, and see whether the harmonics could possibly be heard by you when you're listening or not, or whether it's just a gimmick. We saw that you had to have the control over halfway. The higher you turned it, the more you got from the non-linearity of the valve, introducing the first and second harmonic interference or distortion to make it sound like a valve, if you can hear that distortion. And also we saw that weird behavior with the bass, and I plugged it into my monitor speakers, and you could hear that boomy bass when it's set to the midpoint. You can hear the boomy bass from the bass, where you had that strange gain sort of running flat. It was boosting the bass and lower middle frequencies, and then when you turned it down, it went flat and turned the whole thing down. You could hear that on when using it. So I found when set to the neutral positions, I found it to be quite boomy, like standing outside a room listening to music slightly, not much but slightly. But if you turn this down, it improved it. But I couldn't hear any difference on the distortion. So in the end, I just disconnected this and disconnected my monitors directly to the speakers, and I think I prefer my audio signal path not to go through one of these valve preamps. It's certainly this one anyway. I'd be very keen to try a valve preamp of some other pedigree, one that someone reckons is good, because I don't think this has been very well thought through or designed. But you saw the responses, and if you think it might be for you, it might be worth trying one. It does sound different when it's plugged in, but I think that's just the distortion from the from this tone control circuitry, rather than the actual fact that it's going through the electrons between the cathode and the anode of the valve. I don't think that's making much difference at all, according to the analyzer. That's about it for the review. If you want to hold on past the end, what I call the end of the video, I do an audio test with 0 dBs and minus 53 dB, so you can hear how loud the harmonics are that are produced by this thing. If not, thanks for watching, and hit the subscribe button if you're not subscribed, and if you are, then thank you. So hold on to hear the audio test. Okay, there's no video with it, it's just a boring thing about the sound. Okay, what I'm going to do now is I'm just going to play you a 0 dB 1 kilohertz tone, and then I'm going to play you a minus 53 dB, so 53 B downs on 0 dBs, which is what we saw for the most significant harmonic. Okay, so the microphone is a studio microphone next to a monitor speaker. It's about 6 inches away. I'll set the gain up, so stand by to turn your volume down if you're listening with headphones or something. But this is 1 kilohertz at 0 dB. Okay, now if I just turn that down to minus 53 dBs. Okay, so minus 53 dB is 1 millivolt. It's a thousandth of the signal. That was the biggest harmonic we've received when we're doing the test. Can you hear it? That's minus 53 dBs down on the other signal. I can just, I don't know if you can, there's a bit of noise in this room. I can, put my ear right next to it, I can just about hear it. So basically this doesn't do anything, this valve, these distortion peaks aren't significant. So yeah, it's just a tone control box really, and forget about the valves. And it doesn't work very well as a tone control box either. So that's my take on that. Hope you enjoyed that. If you just look down the bottom right hand side of the screen, you can see a subscribe button. If you could subscribe, I'd appreciate it. And if you're thinking of buying a Nobsound or a Nobsound, I hope this has helped.